see, you will get one window like this. So here there is one application called CAM. You can click on that CAM so that you can get the camera view of that hardware. Here the hardware present is Nucleo G474 board. Suppose if you want to zoom it, then you can zoom it on this one, and if you want to move, you can move also. If you want to unzoom, then you can unzoom the things. And one more thing you have to remember is here there is a one port is present. Here the port number is 50024. Okay, so for this board who are accessing, for them the port number is 50024. For others they may have different port number. This port number is using while dumping the code into this board. Okay. Now let us see how to use the STM32Cube IDE, and we will try to program for the LED blinking of this board. So for opening the STM32Cube IDE, go to Applications and open the terminal emulator. See, after opening the terminal, in the terminal you just try to type STM32Cube IDE in small letters. Okay. After that, press enter. Then it will open the STM32Cube IDE launcher. It will ask where we have to save the workspace. Try to save in the default location where it is showing. Don't try to change the location. If you are using in your own system, then you can save at different workspace location also. Okay, then click on the launch. Then the STM32Cube IDE, like this one window will open. In case if any C files or any project files has been opened, then you can close those projects. Here some project files has been opened. So I am trying to close that project. How to close that project means you can go to that respective project, right click and click on the close project. Suppose in some cases it may take time to load the STM32Cube IDE because sometimes it will try to download some data. Sometimes it will try to download some data and it will try to save. You try to please wait unless it is fully loaded. After that, to open a new project, go to File menu, go to New. Then we are going to create a STM32 project. So click on STM32 project. It is telling in order to benefit for best experience a network connection is required, because the reason is in case if any parameters are required, those parameters it will try to download. Then after that it will like this STM32 on project window it will open. Here you can observe there are different type of selections of our board has been present. The first one is based upon microcontroller unit selection. Second one is board selector. Next one is example selector. Next one is cross selector. We are going to select based upon the board. So go to board selector and try to type that board number. We are using Nucleo G474. So I am typing G474. You can observe it here. Nucleo-G474RE. This is the board which we are going to use. When you have selected that particular board, here that board list it will show. If you want to download any data sheet or regarding the details about that board, you can select it here. After that, you can go and observe it here. Some details about that board has been provided. it's both large picture and document and resources and data. So now let us select this board and then click on next. Then it is asking what is your project name. I am creating my project name is Smart. I am creating my project name as LED Blink. So now in the targeted language of C we are going to generate. So the target binary type we are going to use executable, and targeted project type we are going to use STM32Cube. So click on the finish. Then it is asking, do you want to initialize all peripherals with their default mode? Then click on yes. Then it is asking open associated perspectives. Then you can click on yes. Then it will load IOC file. Now you can observe it here. Let me maximize it. So now you can observe it here. This is our project LED Blink. Okay. So in this one .ioc file has been created. In that we are in a tab pinout and configurations. So now let me zoom this board. See, this is the pin diagram of that STM32G474RE-TX microcontroller. In that you can observe it here, as we have told to set up some default parameters. So this RCC, oscillator out, oscillator in, all those it has been already set. Suppose if you want to move, you can click on this microcontroller and you can move that one. See, if you observe, one LED2 green LED PFI has been already connected. This is the one LED onboard LED which is connected to port A pin number 5. Okay, the same thing you can observe by going to Nucleo G474 board. They may have provided that there is one onboard LED has been present. One user LED shared with Arduino. This is that onboard LED. If you want to see where is that onboard LED, you can go to the camera view and you can observe it here. In the camera view, here one LED is already blinking side to this black color button. That is that onboard LED. See, this is that onboard LED. Suppose if you want to set any other pins, suppose this PS7 is there. In this controller, you just click on that particular pin, then you will get this PS7. What are the options are present for that particular port A pin number 7. See, these all are the options. Suppose if you want to make it as like GPIO input, you can select this GPIO input. Then it will set that particular pin as GPIO input. If you want to remove, click on that one and click on reset state. Next is about clock configurations. Now you can go to here and you can observe that clock. What is that clock here? For this one, the clock is 170 megahertz. Suppose if you want to decrease the clock or increase the clock, using prescalers you can decrease the clock, using PLL you can increase that clock. Here you can observe, let us see how this clock has been generating. See here, system clock 170 megahertz. Suppose if I want to make this clock as 85 megahertz, then I am making this prescaler value as 2. Let me make it as 170 megahertz only. This is that PLL clock. Here, see, from this clock, entire clock, it is generating from 16 megahertz. 16 megahertz, it is generating this 170 megahertz clock using PLL blocks. Okay. So now just see how much clock frequency it is generating. Okay. In case if you are using for other applications like USART, all those things, then that time this clock frequency maybe matters. After that, after you have setting the all these pin parameters and all, then you can go to here this clock configurations. After that, if you want to see this project manager, you can go and observe this project manager. Here this consisting of project name, where is that project location, and toolchain folder location, all those things it will be presented here. So after completing this one, you can go to this tools menu. There this device configuration tool code generation is present. What does it mean? Means we have configured this device, for that it will generate that respective code. That means initializing this port, this PA5 with this as a GPIO output. Similarly, if you make any particular pin as GPIO input, it will initialize. Those all initializations it will do automatically. So click on that one. Then you can observe it here. Open associated perspective. Yes. Now you can observe it here. One main.c file has been created. Okay, where is this file has been present? Means in this LED blink. Now in our LED blink, mainly there are 3 folders are present. One is includes, to include the related tools, what are the tools are required for generating this code and all. After that there is a folder called core. After that drivers. Go to this core. In this core there is a source will be present, src. Go to this src, and then this is that main.c. Okay, here it is our main file. So now you can observe it here. Here they have declared one UART and system clock configuration function has been called. Similarly, GPIO initialization has been happened. Similarly, the UART, what is the object we have created? For that object, it has been called that function for initializing of that one. Suppose if you want to go to this respective function, just select that one and then control plus left click. Then it will take to that function. That function will be present at the down of that code only. You can go to this down. See, this is just function definition. That function declaration will be present after the main. If you go down, see here, this is the declaration of that system clock. This is about the function system clock config. Now they have configured these clocks. After that, similarly UART they have configured. This UART configuration is using for us to dump that code. Okay. Next is about GPIO. Here you can observe here. See, this GPIO LD2 means that GPIO port A. This is LD2 pin is GPIO port A pin number 5. They are telling to make it as a reset. So that means it is 0. This GPIO pin reset value is 0. It will be like as defined, this value has been defined. Now you can observe it here. This is one header file. In that header file they have declared this GPIO pin reset means 0U. Okay. Similarly, whatever the peripheral we want to use, so that respective it will get initialized. So it will just do initialization. So if you go to the main, let me decrease the size. So if you go to the main, this all initialization will be present. After that, this system clock configuration function has been called. After that, GPIO initialization, those functions has been called. After that, there is a while loop. So we are going to write our code, what it has to execute inside this while loop. So before going and writing this code, as during initialization, they have reset that GPIO pin, right? Let me dump this code so that LED should be in reset mode. That means it should be off. Now how to dump this code? Before dumping the code, we have to build our code and we have to check whether any errors are present or not. How to build the code means, you can go to here, this build, click on that, and you can observe it here, build finished, 0 errors, 0 warnings. I have not written any code. The code which has been generated by IDE only, that code only I have built. Now let us try to dump this code. Now how to dump the code? Before dumping the code, we have to confirm what is the port number. For that port number, you can open this camera view and you can go and check the port number. The port number is 50026. If you are not opened that camera view, then you can go to the desktop, double click on this cam executable file. Then it will open like this, one camera view it will open. You can zoom out and zoom in this one like this. Okay. So now here go to this run and click on run configurations. Then run configurations window will open. Then go to debugger. In the debugger, by default it will be present with this auto start local GDB server. But now connect to remote GDB server and then you have to enter the port number, which is 50026, and then click on run. Now it has been dumped, there is no issues. Right now let us check, this LED is off only. Now let us try to switch on the LED and let us see. Okay, and where you have to write the code is after this begin, always you have to remember that we have to write the code in between begin and end. What is the reason why we have to write at there means, suppose if we have done any configuration changes, after that when we try to generate that code file using this tool code generation, that means after we have set the device configuration, we have tried to generate the code using tools, then which is there in between begin and end, that will remain like that. The rest of the code it will get deleted. So that's why try to write after begin. So you can observe it here, user code begin 3. Now I want to set that particular pin to high and I want to dump the code and I want to observe. So now let me go to GPIO. You can observe this is the API call for this GPIO pin. So I will just copy this one. Let me copy fully. So I want to write before while loop itself. Now I want to make it as, instead of reset, I want to make it as set. Remember, if this is in blue color and it should be in italic format, then only it will be like the with as defined at the background, it has defined with some values. Now you can observe it here, it is defined with value 1. Okay. Here you can use like this, or you can use GPIO A. This is port A. What is that pin? What is that pin? You can write it here, which is GPIO underscore pin underscore, what is that pin number? This is pin number 5, which is PA5. Port number A, port A and pin number 5. Now let us try to run this one. First let me save this and then first let us build. There are no errors and warnings. Now let us try to run. Go to run configurations and cross check the project name and then go to debugger. Click to this remote GDB server and your port number, which is 50026. click on the run. Now you can observe it here, the LED is on. Now let us try to write the program for blinking this LED. That means I want to write the program for 1 second to be on and 1 second to be off. So I want to implement that one in the while loop. So copy this one and you can write it here. First it should be on. After that I want to provide a delay. For delay, Hall API call is Hall underscore delay, DELAY. Delay of, you have to provide the value in milliseconds. Suppose I want 1 second delay, then it should be 1000 milliseconds. Next, I want to reset also. So copy, paste. Here instead of set, we want to make as reset. Let me save this one. Run configurations, go to debugger, connect to that particular port number and then click on run. Open the CAM player. Now you can observe it here, this LED, it is blinking for 1 second on, 1 second off. This is a program which you can implement using this remote hardware lab. In the upgraded courses and all, we are going to provide with peripherals and all how to access the different hardwares. As here on board there is only one LED is present, we have shown that one with that LED. In case if you want to write code, then you can write code for user inputs also, all those you can implement. But for providing user input, there will be need of a special provision for providing that input and all. That one in the upcoming courses and all, we are going to provide all those things. Thank you to all.